Okay, welcome back to our for loop demonstration. So we've talked about while loops, but for loops are slightly more structured. And by for, I mean the word for. And a for loop has three main features. First, there's the iterator, declaration, and initialization. Then there is the conditional, or the condition. And then finally there is the iteration part. Okay, so we declare our iterating variable first. And between each of these sections, we're going to have a semicolon. It's going to look like that, semicolon there, and then this one's going to be left off. So let's look at what this looks like. Let's say I want to loop from 0 to, let's say, 10, and print something out each time. So print something out maybe 9 or 10 times, or 10 or 11 times. So for, the way I do it with the while loop is maybe I'd have to make a counter, and then I'd have to say while counter is less than 10, do stuff, right? And then maybe do a counter plus plus. Well, this is sort of all over the place, and while it's sort of a similar amount of work to make a for loop, it's all self-contained, and you always know that you're doing the same things each time. So I'll start for, and typically we're going to use, computer scientists like to use the letter I here for our iterator, int I equals, and we're going to start at 0. And this is sort of like the counter. So instead, I'll use the word counter to make our lives easier. Counter equals 0, semicolon. Now our condition. Counter is less than 10. Okay, semicolon. Then we're going to do our iteration, counter plus plus. For the for loop, it's very structured. It's very clear that all of the things we would use in a while loop are all in one place. We're not going to forget to include anything, and it's pretty much guaranteed that we're going to be going through, if not a definite number of times, at least we have some idea of what the control is going to be. Now, I could leave this blank if I've defined it elsewhere. I could leave this blank, wouldn't be very useful, and I could leave this blank. But I'm not going to do that. I'm going to have it be a full for loop with everything defined. And what am I going to do here? What am I going to do? Well, let's say I want to system.out.println. Maybe I'll just count upward. I'll print out my counter. If I run this, you'll see that I print 0 through 9. If I want to print 0 through 10 or 1 through 10, I can start there and maybe go through 11, and that would certainly work. Or I could go through less than or equal to 10. That would also work. Same exact output. Now maybe I'll want to do something like this with a space in between each number, like that. And that might make it a little clearer to see. But what happens is I print the number and I print a space. Then I iterate. I'll go back up to iterate, and then I'll check my condition. So the order for this is going to be 1, check my condition. 2, execute my statement. 3, increase by 1, or increase by whatever number I choose here. 4, or go back here to my counter. So in this case, I could say counter plus equals 2. I could increase by 2 each time. Let's see how that changes things. well, then I just print my odd numbers. If I want to start at 0, I'll just print my even numbers. So you have a lot of control here, and just by changing a couple small things, it's really easy to see that the for loop provides this advantage of structure.